Well, have you read the sheet? Yes, okay. So here's the deal. You are experts on density. You have proven time and time again that you know the relationship, that's the key word, the relationship between mass and volume. And how when one of those changes, the density changes. Okay? So today, you're going to be a mechanical engineer. You have to engineer a product, a film canister, that can sink to the bottom of a graduated cylinder, one of these large graduated cylinders that you will use today. Okay? They're all in the back there. You can kind of just take a glance real quick back there. There he is, demonstrating where they're at. All right? And you will use one of those graduated cylinders today. We'll fill it with water. And your job will be to get this film canister, and there's something special about it. It's got a hole in it. It's got a hole in the cap. Okay? You have to get this film canister to sink all the way to the bottom of the graduated cylinder. It has to stay there for at least 10 seconds, and then come back up all by itself. Just like, what does that?
Submarine.
Submarines. Can anybody give us a little prior knowledge? How does a submarine work? What do you think? Go ahead, tell everybody. Water buoyancy. What does that mean?
You let water in to the little water tanks and it's like over around the corner and
All right, did you guys hear that?
it's just like big shipping stuff with water.
Okay. So Travis here is saying that basically a submarine will let some water in. What do you think that does to the density? He said it makes it heavier, but let's talk specifically about density. What do you think that does? Does the volume of the submarine change when you let water in? Oh, very good. What do you think that does to the mass? Go ahead, Brianne. Does it increase the mass or decrease it if you let more water in? Anybody want to help her out?
Oh. I'm supposed to answer?
Yeah. Yep, it's going to get more mass. It's going to get heavier. Okay? And so a submarine can change. Would you agree with me that a submarine doesn't change its density? Does a submarine's density always stay the same?
No.
Just because I'm a teacher and man, that guy must know it? You tell me, if I told you, if I came up to you on the street, I said, you know what? A submarine's density, like I never say this on the street, but a submarine's density never changes. It's always the same. Is that a lie?
Yes.
I think I would agree with her. Because I know a submarine goes down in water, but it can also float in water, which means what has to happen to its density? It's got to change. It's got to change. Today, you need to use some of the concepts that you just mentioned here to get this guy to do the same thing. You need to think like that. How can I change the density of this film canister so that it does what I want? Okay? I'm not going to tell you how. I'm not going to give you any hints how. Because I know all of you are smart enough to figure all of this out. And I will give you some tools. You've already read the sheet that I put in front of you. And you see that there are two main things here. Mass and volume. These are the variables that we need to work with. You will have a graduated cylinder like this that you fill with water. Carefully fill with water. They don't fit in the sinks. Some of them are glass. If you're really leery about glass, use one of the plastic graduated cylinders. But your job here is to fill this thing up. You don't have to fill it all the way to the brim. But fill it up just like this. And I've got some things for you. I've got some materials that you're going to need to use. Because I'll tell you right now, you throw this guy in here, there's nothing in it. There's nothing in it. You throw this guy in here, sink or float? Okay? Definitely floats. In fact, what did we do the other day? What did I put in there and it still floated?
Water.
I put water in there. And it still floated. So, all I'm going to tell you is this. I'm going to give you a few things. Over here, you will see there is vinegar in these two beakers. There's some vinegar that you can use. Over here you will see there is some baking soda that you can use. And the scupulas, of course, to get the baking soda out. Over here are film canisters, right? Film canisters. Make sure you get a film canister with a hole. With a hole. That's very important. Okay, very, very important. We'll do a lab later where we put things that go and we put a cap on the film canister with no hole. What happens? It's fun. Make little rockets. So make sure you get one with a hole. You might even want to think about what might be better. A film canister that's kind of, you know, translucent. I can sort of see in there, or one that I can't see what's going on in there. Maybe one might be better than the other. Maybe it doesn't even make a difference to you. Who knows? Your station, your lab station, should look something like this. You've got your graduated cylinder. You've got your film canister. You went and got a beaker and put some of that baking soda in it, so you don't have to keep running back and forth and getting more. Baking soda. But get some vinegar, so you don't have to keep running back and forth and getting vinegar. You'll also come to me, and I will give you some Alka-Seltzer tablets. Are you familiar with these? Are you familiar with these? Don't eat them, okay? Some of them just go fizz-fizz in the water, but some of them are painkillers too, all right? You know, you got an upset stomach, oh, maybe you got an upset stomach and you're kind of feeling, you know, you got some pain, maybe a little feverish, and so they sell these at the store. They're not for eating. But you'll get one whole packet, and in each packet, you'll find a tablet that looks like this. And what you want to do is just that. You want to break it into pieces. So I'm going to tell you right now, this is kind of one of the only hints I'm going to give you. You don't need to use a whole one of these. All right, if you're kind of, because I can see some of you already formulating in your mind, what am I going to do with this thing? So I would break this up into at least 5 or 6 pieces. Try to make them pieces that are equal in size. Okay? If you need more, let me know. But you're going to be limited on how much material you get, because I only have so much. And you will also get, from me, you'll also get pennies. Pennies. All right. All right, pennies. So don't steal my pennies. Not that you ever would. I tell my other class this, because some of the guys, I saw someone do it.
They're shopping for that 89-cent burrito.
That's right. If you need money, let me know. I'll give you some. All right, but don't steal my pennies. All right, I only got so many, and I like to use them for class. All right. So let me know. All right. So I would take probably get about 8 pennies. Just grab about 8 pennies, 5 to 10 pennies, something like that. All right. Take them back to your lab station. Okay. Take them back to your lab station. So what I would like you to do is you're going to work. You don't have to be right at a sink. Okay. You don't have to be, but spread out like we do usually. Get the water out of the sink. Okay. And I've even got some other containers that that are shorter and fatter. Now here's the thing, I'll tell you what, when that guy sinks, when you get him to sink, because I know you will, but when he sinks, how do you get him back out? Let's see if he can come back up. Well, yeah, you might, maybe you can give it, come on, please, or you can pray, or you can just, oh, okay, something like that. And you start, wow, it starts rising. But really, honestly, guys, you probably have to just do this all the time. You have to just empty out the water, or maybe put your hand on the top and let them come down and then grab them. Take them out, maybe leave some of that water in here. But point being, you'll probably make a little bit of a mess, and that's good. That's fun, okay? Baking soda, vinegar, all this stuff, but in the end, make sure you clean up well, okay? So what's your goal? To get the sink, stay down there, and then come back up, okay? And then come back up, right? So what I'm going to do is I'm going to have you work in the groups that you worked with in your density lab. That last lab that you just did, those are going to be the same groups. I've got the graduated cylinders in the back. I've got all the chemicals that you need, plus the film canisters over here. And then over here, Mrs. Brooks, if you wouldn't mind helping me out, we're going to dole out the Alka-Seltzer tablets and the pennies. Okay? And you just get one packet for right now. Any questions? What questions do you have? Yes, sir. Do you need to use? That is a great question. Do you need to use all the materials? No. I've given you a potpourri of chemicals, just a bunch of stuff, okay? And you don't really know yet what might work or what might not work. That's for you to figure out. You have to figure out a solution on your own. I know you have background. I know you have some prior knowledge as to what happens with baking soda and vinegar when you mix them. And what happens with an Alka-Seltzer tablet when you put it in water? What happens? It fizzes. It makes gas. That might be a key to your success today, okay? So, long story short, figure it out. I know you'll do a great job. I know you'll do a great job. And then, after that, we're going to talk a little bit as you see some minor successes happening around. You hear people cheering. You're kind of wondering what's going on. Start maybe asking some questions a little bit, okay? All right? Me and Mrs. Brooks can't tell you any answers. We can't tell you how to do it, but I know you'll figure that out, okay? So let's get started with that. Go ahead and get your chemicals. Make sure you're keeping each other in check. Remember, you've got a partner. That means you can do something, and they can do something else. So don't forget to work together. Help each other out. They're allowed one.
You gotta break it. Shit. Oh, why'd you break it? Why'd you break it? Yeah. Are you still recording? Are you just gonna cut it?
Some of these are kind of... You gotta have one with a hole.
Have you ever used a monopod? It's so much better than tripods. Because you can just set them down.
If you need a fill canister with holes, I can give you one. You guys got a fill canister yet? There is still a fill canister.
Our recording.
You might want to run a few tests. You might want to run a few experiments on what this fill canister does all by itself.
One smart dude.
Take a little water.
I know. Are you going to film me?
I think, yep. Somebody mentioned to me that probably one of the most important things is to get that guy to sink first. Just dump it out. Yeah.
Once you put it in there, it'll get
You
water.
don't need to go far. So I would work on getting that fill canister to sink first. Yep.
Okay, let's get it going first. Get it going. Just a little bit slow.
Did you get the baking soda? Excuse me.
Now they're putting us under pressure. If we do it wrong, video cameras gonna see.
That's good. Yeah, fine, right? It's not gonna sink.
Yeah, we need more pennies in it. It's just gonna shoot right out.
That was a duck.
You can delete that off your camera now. Thank you.
Make sure you guys have your goggles on. So you need to wear goggles. So I give you one more warning. And if you don't have something covering your eyes, you will get marked down on your lab. So you definitely need to get something on your eyeball. So you don't want to be like Carol. Oh!
I did it.
All right, keep it down.
It worked.
It went all the way down. It was down. Wait, it wasn't all the way down there for.
Let's go grab 2 more pennies.
What'd you guys have in it?
He had like all their pennies and one of these.
Okay.
And then when we got down there, it kind of reacted. We put it upside down and it reacted, and then it shot back up.
Did you have water in it? No water in it?
No, we put water in it for like and then I put the cap on through.
Okay. That's good. How many pennies did you guys have? Just curious. All right.
We're gonna put some more in it.
Great, man. That's awesome. Good. See if you can stay down there for at least 10 seconds. At least 10 seconds.
Oh, we'll get ours to stay down forever.
Oh, the graduates.
We're gonna have to keep them too.
Are you going to put one of these, some of this in there?
You know what? That's alright. I'm just gonna use. Let's just use this. Same difference. It just doesn't have as far to go.
I broke it up. This side has this.
As soon as they notice, you get a scram.
What?
Yeah, how's it going, buddy?
Take that one.
Okay, so what can we do to get this thing synced? We tried already. Okay, how'd you sync it? Okay, just all pennies? No water or any baking soda? How'd you get it to sync the first time?
Just the pennies. And
Okay.
No, we already did it. We made it. 2 is not even enough at all. We put like 10 in there and it works for about 10 seconds. It's not gonna work. Want to stop it out?
Oh, we got a minute. That was on there.
Yeah, it's not gonna come out. Maybe. Let's wait.
Just leave it. They stopped bubbling last time.
Yeah.
Did you guys get it to sync?
Give it time to stop bubbling.
What have you tried so far?
Did you put the stuff on the bottom last time? The alcohol stuff?
It doesn't matter. It's all in a closed container. What? It does?
we gotta do all the cells here. And then within there.
Sounds good. You sure it's not gonna work?
Well, last time it stopped bubbling. We're waiting for it to wait.
Last time we put it at the top and it worked.
So we gotta do is fill this with water.
Scientists are keeping records of what you're trying each time.
That'd be pretty amazing. Yep, don't forget, like Mrs. Brooks said, keep a record of what you've tried. What have you used? What are some of the chemicals that you've tried? What is it?
What are these even doing?
Arms almost, it'll come. Give some time. How long's it been down there?
You got it?
So it finally filled with water, it's up, right?
Yeah.
But see, that's the key, is you sort of want it to sink. Then you want it to fill with the air so it'll come back up, right?
So now we can do it over.
Exactly.
What happened to the great student of the day?
That was yesterday.
Should have gotten on the first try.
Oh, wait.
It's in a reactor right next to water.
Oh. 1, 2, 3, 4, 5, 6. Hey, come back up.
I think you might have done something a little wrong on that one.
No, she did right.
Come on.
Come on, start praying.
It could be a new world record.
Make sure it's
Oh,
not
wait. It might come back up. That's bubbling. Oh, it's coming.
Not one more.
They got theirs to work and it was like
Oh yeah, the one we did.
great.
For the interruption, soccer team needs to be replaced.
Terrible.
Terrible.
Yes.
So why is it terrible? What's so terrible about it?
It's just terrible.
Have you gotten it to sink yet?
No.
Okay.
We only have 7 pennies and it's too light.
Still full. So what do you do to change that? Nothing?
Yeah, we're still thinking.
You just think it might float, but still, with 7 pennies and alka-seltzer? Might help to change it, right? Okay. What are some things you can do to maybe change it? Add more weight? How can you add more weight? Okay. Try, I'll give you a little hint. Try, instead of pennies, try adding something else. So would you agree with me that maybe it would be possible to actually make it so heavy that it would never come back up? Like maybe so many pennies that it's never, no matter what you do, it will come back up. Try adding something else. Alright? Remember, you've got baking soda, vinegar, and water. Don't forget that you have water as well. Use water in the tap.
Does the sink stay down for 10 seconds?
Alka-Seltzer tablets. He says that he's got it. He's getting his stuff together. Okay, I'm gonna check on something too. Good job measuring. That's good.
Did you stick the ingredient in? Alright, we're changing it this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know it stayed down long enough. Now we just gotta see 13, 14, 18.
Yeah, what do you got in there?
I got diluted acid,
We'll get some papers.
tablets, and worked last time.
No. You're the one making the
It's kind of harder to see it in this one. See, it's funny how we stand back when something's going to happen.
Hey, Mr. Schultz.
1 minute.
Sit down for 11 seconds.
Good job, Garrett. Nice work. Did you count how long you stayed down for?
It was past 10 seconds.
Quickly, go ahead.
Hey, we got to stay down.
11 seconds?
And it came right back up.
So, once you get a success, once you have success, listen up, look this way, look this way. Everybody stop what you're doing, look this way. Okay? Tanner? Once you get a success, good job by the way. Once you have success, here's what you need to do. You need to write down exactly what you used. Okay? You need to write down exactly what you used. And then, make sure, try to make it better. Try to get it to stay down there longer. How can you tweak it just a little bit to make it better? Okay? Alright? Everybody, all at once. Get yours ready. You got these guys.
I'm ready.
Are you ready? Let's start timing. You ready? On your mark. Get set. Go. Go, go, go.
We had 10 seconds.
Alright, so we're counting. Let me know when yours starts coming up.
That was sad.
Yours came up. Go ahead.
Oh, but there's a...
How about back here? Is it coming up back here?
Oh, it stinks.
Did you guys do it? Are you guys doing it? No?
We had it, but it's gone now.
Go. We got this.
The lid out. Yep.
Oh, there it is. Stay. Yeah.
Count it. How long is it going? What do you got? 5 seconds? It's working his magic.
Yeah.
Little engineers. Oh.
Oh.
Nice.
Oh. Yeah. Right.